In this lecture, we will discuss about the voltmeter, and voltmeter is actually the modified form of the galvanometer. In the previous lectures, we discussed about the construction and working principle of the galvanometer. Okay, so galvanometer is such like device. Here in this circuit diagram, we have the galvanometer, and if we connect the resistor in series with this galvanometer, then we will call this galvanometer as voltmeter. Okay. So whenever you find the potential difference across the component of the circuit, so let's say we have this component is a resistor in a circuit, and if someone asks you to find the potential difference across this resistor, then you will put the voltmeter in parallel with this component. Okay, this is the voltmeter, and you will put that voltmeter in parallel with this component of the circuit. So here at this position we will have some potential, and similarly at this position we will have some potential, and if we subtract that potential, then we will call that as a potential difference, and that will show here is the pointer of this voltmeter. So inside this voltmeter, we have the galvanometer, and which is attached in series with the other resistor. We have this galvanometer, and which is attached in series with the other resistor. And in this case, we call this resistor as high resistor, and having resistance is RH. So this the value of this resistor will be high, because here if you find the potential difference across this component of the circuit, so let's say the current I is flowing in that circuit, and we call that as I. So here at this position, at this junction, according to Kirchhoff's current law, this current will be divided, and some of the current will pass through this voltmeter, and some of the current will pass through this resistor. So in this case, we don't want to pass the current through this voltmeter. Okay, so for that we will have to increase the resistance of this voltmeter. So therefore we insert the high resistor inside this voltmeter. Okay, this is actually voltmeter, and inside that voltmeter we have the high resistance. So if the resistance is high, then less current will pass through this voltmeter. So if we provide the current through this voltmeter, that current first will pass through this resistor, which is called RH, a high resistor. Okay, then after that the current will pass through this galvanometer. Okay, and that galvanometer have resistance which is called RG, and the current through the galvanometer is given by Ig. Okay, and the current through this resistor is given by Is. Okay, IH. Okay, in this case, these two components, the resistor and the galvanometer, are connected in series with each other. So if the components are in series with each other, then the current passing through that all component will be the same. So here, according to that rule, the current Ig, the current of this galvanometer will be equal to the current through this high resistor. Okay, IH. These will be equal, and the potential, the voltage through each component. So the voltage to this high resistor and the voltage through this galvanometer will be different. Okay, so for that we can write here is that the total voltage is equal to the voltage through this resistor, okay, which is VH, plus the voltage through this galvanometer, which is the VG. Okay, So here, according to the Ohm law, V is equal to IR. So V is equal to, for this we can write I, okay, and R. So this is for high resistor. For this high resistor, okay. So this become IH and RH, and then plus, and this is IG and RG. Okay. So here is we know that these resistor and this galvanometer are connected in series. So if the component are in series, the current passing through that will be same. So instead of this IH, we can write the IG. So here this will become V is equal to IG and RH plus IG and RG. Okay. So from this we can determine the RHS. So this IG RH is equal to V minus IG RG. So this a term is shifted toward this side, and that will be with the negative sign. So V minus this term, okay, which is equal to IG RH. So from here, RH is given by V minus IG, okay, and RG divided by this IG. So we can further simplify this as RH is equal to V divided by IG and minus IGRG divided by IG. So this IG and IG will be cancelled, and this will become RH is equal to V divided by IG and minus RG. So from here we conclude that if we put the resistor having this value in series with the galvanometer, then that galvanometer will be converted to the voltmeter. Here in this case, if we connect the voltmeter in parallel with the component of the circuit, and here inside this voltmeter we will have a pointer, okay, and that pointer will show some deflection, and in this pointer this deflection is not due to the voltage, but this is due to the current. Okay, so if we multiply that current uh, current is same here, IG. If we multiply that current with the resistance, and here the resistance is given by RG plus RH. So if we multiply the current with this value RG plus RH, then it will give us the voltage. Okay, so the deflection of this voltage, the deflection of the pointer in this voltmeter is not due to the voltage, but that is due to the current. And if we multiply that current with the resistance of the voltage, or the resistance of the voltmeter, then we will call that as a voltage. Okay, so this was about today's lecture, and that's it, guys. Thanks for watching.